Our TRIAGE pipeline integrity, hazard classification, and mitigation guidance is a data service that provides the foundation for a quality, performance-based integrity management program. TRIAGE has been proven to reduce and even eliminate pipeline failures while delivering a 45% savings and direct mitigation costs compared to application of conventional industry standard methods. This image demonstrates how we incorporate standard NACE, DeWard and Williams CO2 corrosion rate models in combination and within consideration of the critical inclination angle to promote stagnant water holdup in the pipelines. Secondly, we consider whether upstream producing wells are likely to have incubated corrosive biomass goo as a byproduct of drilling operations, and with consideration of the dormant period between drilling and the date of first production. Finally, we consider whether the hydraulics associated with well startup procedures are likely to uplift the corrosive biomass sludge into the connected pipeline system. The TRIAGE algorithms translate the factors included within the corrosion triangle into a mathematical severity score. Based upon the TRIAGE severity score, we publish a hierarchy of mitigation options. For Group 5 pipelines, the mitigation guidance is designed to prevent the growth of pre-existing corrosion damage. For Groups 3 and 4, the objective is to mobilize the water film or condition the water film to avoid the initiation of new corrosion damage. For pipelines in Group 1 and 2, never considered vulnerable to internal corrosion at any time in their lifetime, there is no mitigation necessary. This is a brief tour of the TRIAGE mitigation guidance table and a demonstration of how field teams consider their knowledge of the system and experience to create the most cost-effective mitigation schedules for each pipeline. The first step is to consider if overlife pigging at the minimum suggested frequency has been performed reliably over the operating life. In the case where operational pigging has been performed, the mechanical removal of stagnant water has prevented the initiation of potential corrosion damage, and there is no need to schedule any additional mitigation. For those pipelines where the objective is to prevent new corrosion from initiating, there is a suggestion to implement pigging. The suggested pigging frequency considers the water transport and severity of potential water traps. In the situation where pre-existing corrosion is expected, there is a suggestion to apply a heavy batch inhibitor film between pigs at a frequency aligned to the severity of the corrosive environment. The guidance suggests a frequency, a batch inhibitor slug size, and a corresponding hydrocarbon diluent volume. The calculation of the batch inhibitor considers pipeline surface area, the speed of travel of the pig train, so that the contact time during the batching process assures an effective transport or a transfer of inhibitor onto the pipeline surface. If a pipeline cannot accept a pig or is not capable of effectively transporting the pig, the mitigation chart suggests the injection of a continuous inhibitor with consideration of the water film dynamics. If there is a free water film at the beginning of the pipeline, a water-based amine is suggested. If the pipeline is vulnerable to condensation of water beginning at some point along the pipeline and a free water film does not exist throughout the entire structure, then the mitigation chart suggests the use of a volatile corrosion inhibitor. This option assures that the corrosion inhibitor will be transported with the vapor and it will elevate the pH of any water trap that it encounters along the entire route of the pipeline. Depending upon the time of travel for the water film, there is an option for slugging inhibited glycol into the pipe. The mixture of glycol and water in regions of stagnant traps prevents the localized pH from dropping into a corrosive range below pH 7. We would be thrilled to have the opportunity to speak with you online about how a TRIAGE project can elevate your understanding of the integrity hazards that your pipelines face as a complement to your existing work processes. Thank you for watching this video post.